In a world where daylight rules movement, noise, and life itself, there exist creatures that awaken only when night falls. Owls, silent shadows of wings, spirits of fields and forests, can see where our vision dissolves into darkness. Their eyes catch motion that no other being can perceive. Their hearing pierces through layers of snow, leaves, and the stillness of night, as if every particle of the world carried its own secret voice. And when they fly, there is nothing, not a whisper of a feather, not a single beat of a wing, only the night becoming slightly colder, as if something had just slipped past unnoticed. For thousands of years, owls have stirred awe, fear, and reverence in human hearts. In myths, they were guardians of secrets, symbols of wisdom, guides of wandering souls. In nature, they stand as flawless hunters, masters of camouflage, and among the most extraordinary predators our planet has ever known. And owl is not a single bird, but an entire nocturnal dynasty, over 260 species spread across nearly the whole Earth, from the frozen emptiness of the Arctic to steamy jungles, from scorching steppes to urban parks. If there is night somewhere, there is likely an owl as well. Yet all of them, no matter their size or home, belong to two ancient lineages more different than most people realize. The first are the barn owls, a family with an appearance unlike any other. They bear heart-shaped, pale masks, as if carved from moonlight itself. This mask acts like a living radar, capturing sounds and guiding them straight into their finely tuned ears. Barn owls have long legs, slender bodies, and delicate, almost porcelain plumage. The most familiar of them, the common barn owl, inhabits ruins, barns, attics, places where humans glimpse it only in passing, like a ghost slipping between rafters. Others, African or Australian species, live in tropics, on windswept plains, among rocks, forming one of the most widespread empires in the avian world. The second lineage is the true owls, heavier, sturdier, with rounded heads and formidable talons. This is where all the iconic owls belong, the tawny owls, the eagle owls. From the tiny pygmy owl no larger than a clenched fist, to the majestic eagle owl capable of hunting prey bigger than itself. Whether is a barn owl with a face like the moon, or an eagle owl with eyes glowing like embers, the mystery remains the same. A bird that has mastered darkness better than any other creature on our planet. An owl's eyes are not ordinary instruments for seeing. They are specialized telescopes built for work in the void. In proportion to the size of the head, they are gigantic, the largest among all birds. In most species, they occupy nearly 1/3 of the skull's volume, taking up so much space there is no room left for any sort of movable eyeball. That is why an owl cannot shift its gaze by moving its eyes. It must turn its entire head, performing those legendary 270-degree rotations to take in what its fixed forward vision cannot reach. Their placement at the front of the skull grants full spatial perception. An owl looks like a predator, not like a bird. It sees in 3 dimensions. It judges distance with surgical precision, and does so even when the light is so faint other animals would perceive nothing but darkness. This is why owls can hunt mice in absolute silence and near total darkness. Their vision is not merely good, it is ruthlessly specialized. Inside the eye lies what makes this organ so extraordinary: an immense number of rod cells, sensitive to the faintest traces of light. Owls possess several times more rods than humans, and each one works like a microscopic photon trap. Thanks to this, an owl can see where the light is 1,000,000 times dimmer than in daylight. Its pupils expand so wide they almost swallow the iris, forming a great black lens ready to absorb even the smallest glimmer dot. At the same time, owls see somewhat poorly up close. Their eyes are pushed outward toward the world, optimized for long distances, for the focal range of a hunter. The space near the beak appears to them blurred, but this is no drawback. They rely on touch and hearing for the near world, and where human senses begin to fail, an owl's perception is only beginning to unfold. Their eyes serve primarily to detect shape and movement. When prey hides in grass or beneath snow, the owl's sight may no longer reveal anything, but it is precisely then that the other senses awaken, and the eyes become merely instruments guiding the rest of the body through silence, darkness. In perfect harmony with the night. An owl's ears are a structure so astonishing that many of its abilities verge on something one could almost call a biological radar. At first glance, an owl's head appears smooth and round. But beneath the feathers lies a complex architecture of resonators, funnels, and asymmetries, together forming one of the most perfect sound-locating systems in the animal kingdom. Asterisk. The most important feature. Owls hear in 3 dimensions. It's not just about where a sound comes from, but from what exact height. In most animals, the ears sit symmetrically. In owls, they almost never do. One is placed higher, the other lower. Sometimes one is larger, the other smaller. Sound enters each at a different moment and at a slightly different angle. This difference, sometimes shorter than 1/10,000th of a second, allows them to pinpoint the position of prey with an accuracy of a few centimeters. And all of it in complete darkness. When an owl hunts on a snowy night, its eyes see only a white surface, but its ears hear every whisper beneath the snow. A tiny mouse under a layer of powder creates, for the owl, an entire symphony: the scratch of tiny claws, the crackle of stems, the tap of a tail on ice. Sounds so faint a human ear would register nothing at all. For the owl, that is enough to set its head at the perfect angle and launch an attack in which there is no chance. It does not need to see. It knows. The second key to its hearing is the facial disc, the circular arrangement of feathers around the eyes that works like a satellite dish. These feathers are not ordinary fluff. Each acts like a micro-antenna, capturing sound waves and directing them toward the ears. An owl can tense and relax these feathers, reshaping them like movable reflectors. In practice, this means it can focus its hearing on a chosen source like a living directional antenna. Some species, like the long-eared owl or the eagle owl, have feathered tufts on their heads that resemble ears. But these are mere ornaments, decoys for predators and tools of communication. The real ears sit hidden deep beneath the plumage, perfectly insulated and positioned to form a natural sonar. In extreme cases, owls can locate sounds that no mammal, except the most specialized predators, can hear. They perceive frequencies that for most creatures are too faint or too brief. To them, a rustle is a map of the terrain, a breath is a beacon, and the tremble of a single blade of grass is a signal of life. This is why owls are regarded as the true masters of nighttime hunting. Their ears do not merely register the world. They interpret it, shaping it into a spatial reality where every mouse is louder than the wind. Every rustle sounds like the echo of a future strike. And every silence is only a pause between the next set of clues that will guide them unerringly toward their target. An owl's plumage is true natural engineering, one of the most sophisticated solutions in the avian world. Every feather is designed to combine silent aerodynamics, thermal insulation, camouflage, and sensory support. An owl's flight is almost completely noiseless, thanks to several remarkable adaptations. The edges of the primary feathers, the main wing feathers, have fine, hair-like fringes that break the air into hundreds of tiny vortices instead of forming a single loud stream. This prevents the turbulence that would reveal its presence, even when flying just above the ground or snow. The surface of the feathers is not smooth. Microscopic filaments cover each one, acting as a natural noise-dampening filter. Air does not bounce off them like a rigid surface. It is absorbed by the soft structure, making every wing beat virtually silent. Additionally, the feathers are loose and flexible, working like shock absorbers to absorb air vibrations and minimize sounds that could give the owl away while hunting. Feathers also provide insulation. Dense down traps heat, protecting the owl's body from the chill of the night and muffling the sounds generated by muscles or the heartbeat. Even the most alert animals nearby fail to detect its presence. Some species have specialized cover feathers on their legs and torso, adding protection against wind and cold while further dampening the subtle noises of their own bodies. The coloration and patterns of the feathers are equally sophisticated. Spots, streaks, and bars act as camouflage in various environments. On a branch, the owl blends seamlessly with bark. On snow, its silhouette merges with icy clumps. Owls can adjust their feathers to deform the shape of their body, altering the contours of head and torso, making them nearly invisible even at close range. The facial disc of feathers functions as a natural acoustic antenna. The feathers around the eyes and beak are stiff and precisely arranged, channeling sound toward the asymmetrical ears. This allows owls to hear in 3 dimensions, pinpoint the location of a sound to within a few centimeters, and detect prey hidden under snow, leaves, or dense grass. By adjusting these feathers, an owl can focus its hearing on a specific point in space like a living radar. Some feathers of the wings and tail have self-cleaning properties. During flight, dust, pollen, or small debris slide off or are removed thanks to the delicate structure of hooks and filaments. Maintaining both aerodynamic efficiency and silence. An owl's plumage therefore integrates multiple functions. It muffles sound, protects against cold, provides camouflage, enhances hearing, and preserves aerodynamic performance. Because of this, an owl not only flies silently, but becomes nearly invisible and undetectable to both prey and predators, making it the ultimate master of nocturnal hunting and the living. Symbol of biological precision. An owl's talons are absolutely perfect tools, designed to seize and hold prey with a precision any predator would envy. Each claw is curved at an ideal angle to sink into the prey's body, while the muscles of the legs and feet function like a hydraulic mechanism. The grip strengthens automatically as pressure increases. Even when chasing a swift mouse or a startled bird, the talons snap shut in a fraction of a second, leaving no chance of escape. An owl has 4 toes on each foot, 2 facing forward and 2 backward, and some species can rotate 1 toe, creating a powerful 2-handed grasp. This allows them to catch prey of varying sizes and shapes, enhancing their hunting versatility. The strength of the talons is immense relative to the owl's body weight. Small owls can lift prey nearly twice their own mass, while larger species can carry rabbits or birds the size of a chicken. The beak is another tool of perfection. Short, curved, and razor-sharp, it is designed for tearing flesh, dividing prey into manageable pieces, and precise cleaning of the catch. The beak is not used for grasping. Its role is slicing, segmenting, and consuming. The jawbones and beak muscles can exert enough force to pierce insect exoskeletons, and in larger species, to separate the vertebrae of small mammals. Talons and beak work in flawless synchrony. The talons immobilize the prey, while the beak tears it apart, sometimes even mid-flight. This combination of grip and cut is so effective that most prey never has a chance to react. Even in snow or thick grass, the talons stabilize the owl, enabling lightning-fast, precise strikes. It's worth noting that talons and beak are also instruments of environmental manipulation. Owls can use them to lift leaves, remove obstacles, or even extract small creatures from hiding places. Every part of the raptor's limbs and beak functions as an element of a complex biological system, masterfully integrated. Silent and lethal. An owl's flight is more than mere movement through space. It is a precise, biological dance with the air, combining strength, agility, and absolute silence. The main secret lies in the construction of its wings and feathers. Each primary feather has soft, hair-like edges that split the air, eliminating turbulence. This allows the owl to glide from branch to branch, or over a field full of prey without revealing its presence. Even to the most vigilant animals. An owl's wings are broad and rounded, enabling slow, controlled flight. This is not the rapid, dynamic flight of a hawk. It is a flight that allows meticulous observation of the terrain, assessment of distance, and preparation for the perfect moment to strike. Every wing movement is carefully calculated. The owl can slow, hover almost like a helicopter, and then suddenly change its trajectory to align with the ground or strike its prey unexpectedly. Moreover, an owl's flight is incredibly energy efficient. The shape of the wings and feathers minimizes air resistance, and the muscles work in harmony with aerodynamics, allowing prolonged patrols without fatigue. Even during a silent glide over a field, owls can maintain constant height and speed, virtually undetectable to their prey. Some species use their flight for strategic camouflage. The wings and tail act as stabilizers, allowing changes in direction vertically or horizontally with minimal noise. This enables the owl to navigate obstacles in dense forests or launch surprise attacks at night. When every branch and leaf could betray a hunter. An owl's flight is also a sense in motion. Speed and trajectory allow it to detect subtle changes in the air, the movement of insects, vibrations of animals beneath the snow, or airflow over the grass. Thanks to this, the owl does not need to see everything to strike with precision. The combination of silent aerodynamics, precise movement, and active environmental sensing makes an owl's flight a true masterpiece of nature. In short, an owl's flight is more than movement. It is strategy, weapon, and survival tool all in one. Every twist of the wings, every whisper of air, every correction in flight is part of a precise system of hunting and spatial awareness. It is a skill that has elevated owls to the top of nocturnal predators, not through brute strength alone, but through absolute mastery of the air around them. An owl's wings are absolutely unique in the avian world, and they largely determine its status as a nocturnal predator. At first glance, they resemble the wings of other birds, with flight feathers, muscles, and a shoulder joint, but their details are brilliantly engineered by nature. First and foremost, the edges of an owl's primary feathers are soft and hair-like. In other birds, air flows over the wing, creating turbulence and noise, especially at high speeds. In owls, these turbulences are almost entirely eliminated. Each feather acts as a microfilter, dividing and smoothing the airflow, allowing the owl to move almost silently. This enables it to approach its prey before the slightest hint of a predator is detected. Another difference lies in the proportions of the wings. Owl wings are broad and rounded, far more so than those of hawks or falcons. This allows the owl to fly slowly, maintain full control, and even hover when needed. While other predators rely on speed for hunting, the owl depends on silence and precision. Equally important are the tail structure and wing muscles. The tail acts as a rudder, permitting sudden changes in direction with minimal noise, while the muscles allow controlled gliding over the ground. The owl does not beat the air like some birds. It moves through it as if it were part of the wind itself. Thanks to these features, the owl becomes an almost invisible predator. Even with its large size and impressive wingspan, its movements remain nearly imperceptible to prey. The combination of soft feathers, broad wings, slow flight capability, and precise aerial control makes it a master of nocturnal hunting. A bird that sees and hears everything while remaining itself unseen. An owl's hunt is no ordinary hunt. It is a precise sequence of actions, where every sense, every muscle, and every wing beat work together like components of a brilliantly engineered machine. Owls do not chase their prey like falcons, nor do they soar to great heights like eagles. Their method is subtler, more refined, more nocturnal. It all begins with silence. The owl perches on a branch, often slightly tilted, ready to spring into the air at any moment. Its body remains perfectly still, yet its senses are on high alert. Its eyes, enormous and fixed in their sockets, scan the surroundings. They detect movement where humans would see only a uniform black blur. Every tiny twitch of a mouse is betrayed by the contrast between shadow and the light, reflected from its fur. But it is not sight that rules the hunt. The true pursuit begins when the owl listens. Its asymmetrical ears allow it to capture sound coming from beneath layers of snow, dry grass, or leaves. The owl can pinpoint its prey not only by direction but also by depth. When a mouse scratches the ground, the owl knows whether it is under a crust of snow or just beside a beaten path. Once the target is located, a decision is made. The owl does not dive immediately. Sometimes it waits a minute, 2, or even 5. It waits for the perfect moment, when the prey is sufficiently exposed, when the wind blows from the right direction, when nothing interferes with the sound's. And then, the strike. The owl launches from the branch almost without a sound. It does not beat the air like other birds, but lets its broad wings glide through the night. The first phase of flight is swift, yet nearly completely silent. Its gaze is fixed forward, but its hearing is constantly at work. If the prey changes direction, the owl does the same. Then comes the final phase, the last meters, where the owl accelerates sharply but remains silent. In this moment, its entire body shifts into strike mode. Wings lift gently. The tail stabilizes the flight path, and the legs shoot forward with extended talons like a trap. The talons can grip with a force of dozens of kilograms per square centimeter, and their shape ensures an immediate, irreversible hold. In many cases, the prey dies before the owl even touches the ground. Such is the strength and precision of the attack. But the work is not over. The owl must lift off with its catch, often heavier than one might think it could carry. Wing muscles and the lightness of its feathers help it rise back into the darkness. where the owl begins its feast on a branch or in a hollow. Sometimes hunting looks different. Some owls, like barn owls, patrol fields with slow, even flight, skimming just above the grass as if they were a living drone scanning the terrain. They fly while listening, ready to hover in place and swoop down in a fraction of a second. Others, like the great horned owl, hunt from ambush, using their powerful size and strength to take prey nearly their own size. Some species combine sound and movement in extraordinary ways. Certain owls can almost entirely turn off their wings, transitioning into a silent glide, an incredible feat. Unmatched by any other predatory bird. An owl's hunt is a blend of physics, biology, and evolutionary genius. It is a strategy built on silence, spatial analysis, and perfect timing. These are hunts that require no chase. Because the prey does not even realize the hunt has begun, owls are masters of precise feeding. What for many predators requires tearing, cutting, or dividing is for the owl simpler, yet no less fascinating. They swallow their prey whole. Mice, rats, birds, sometimes even small rabbits. Everything slides into their beak to vanish into a powerful esophagus. Their stomach is a true biological machine, a strongly muscled organ and gastric. Juices work in tandem to separate what is digestible from what is not. Bones, fur, feathers, and other indigestible parts are not wasted. They are formed into characteristic pellets, which the owl regurgitates after a few hours. It is remarkable how owls handle prey larger than their own head. The beak and powerful throat muscles allow the esophagus to stretch flexibly, while the legs and talons stabilize the catch during swallowing. As a mouse disappears into the owl's body, the predator wastes not a second. The entire process is fast and almost silent, just like the rest of its hunting. Some species specialize in swallowing very specific prey. Barn owls often focus on field rodents, while hawk owls can swallow small birds or insects. It makes no difference whether the prey is moving or already dead. The owl's physiology enables swift, efficient ingestion. The pellet that the owl later expels is a miniature natural history museum. Researchers can identify the prey species from hours or even days before, counting bones and teeth in these compact balls. It also demonstrates that the owl's diet is closely matched to its energy needs. All digestible components enter the digestive system, while the rest is naturally expelled without burdening the body. Interestingly, young owls learn to swallow whole gradually. At first, they try biting the prey, experimenting with their beak and stomach, and only after a few weeks do they become masters of swallowing. Learning this process is essential for survival. Without the ability to quickly and effectively consume prey, young owls would be easy targets for predators and hunger alike. By swallowing whole, the owl minimizes the time in contact with the prey, reducing the risk of injury from claws or teeth. It is a strategy that combines safety with energy efficiency. Every movement, from capture through positioning the prey to swallowing, is meticulously optimized by millions of years of evolution. Through this method, the owl becomes an almost perfect nocturnal predator, silent, efficient, and invisible, with a diet adapted to its lifestyle. What seems brutal to humans is, for the owl, simply the logic of survival, a combination of precision, strength, and impeccable timing that makes the night its kingdom. Young owls enter the world of hunting gradually, learning from their parents what is instinct for an adult. At first, they watch as mother or father move through the night, select prey, strike silently, and swallow the catch whole. Every movement of the adult is a lesson. How to position the wings, how to land quietly, how to grasp prey with talons and beak. The first attempts of the young are clumsy. They often lose their prey, misjudge flight direction, or grasp a mouse imprecisely. Yet even these failures have meaning. They teach coordination, control of wing muscles, precision of the talons, and reflex. Gradually, the young learn that swallowing prey whole requires the right body positioning, and each mistake is a lesson in minimizing risk. Parents often bring partially digested prey or leave live prey in the nest so the young can practice grasping and swallowing. This training is not brutal. It is a natural preparation for independent life. The young also learn to recognize the sounds of prey, the rustle of a mouse in the grass, the flutter of a small bird's wings, or the vibration of an insect. This is crucial because at night, sharp eyesight alone is not enough. Hearing and spatial orientation become vital tools for survival. As hunting skills develop, so does the young owl's ability to digest efficiently and form pellets. They observe adults swallowing prey and later expelling indigestible remains. In this way, the young learn not only the physical side of feeding but also the importance of selective energy use and waste management. Each pellet is a lesson: what is digestible, what is not, and how best to utilize each catch. The process of learning to hunt can take weeks, and in larger species, even months. It is not just about mastering the grip or swallowing, it is training the whole system: flight coordination, precision of grasp, breath control, adaptation to nocturnal conditions, and observation of prey movements. When young owls finally leave the nest, they are fully equipped with the knowledge and skills to become silent, efficient hunters of the night. What to an outside observer seems like simple instinct is, in reality, a combination of experience, learning, and evolutionarily shaped physiology. Every exercise, every mistake, and every observation of the adults builds the young bird into a precise predator, capable of surviving in darkness, capturing prey, and perpetuating the cycle of life. Owls are masters of the night, yet their lives are not confined solely to darkness. While most species are naturally adapted to nocturnal life, during the day they retreat to the shadows of trees, dense canopies, or rocky crevices, resting and regenerating energy. Their enormous eyes, fine-tuned to capture even the faintest light, make them incredible night hunters, capable of spotting the slightest movement of a mouse against the backdrop of foliage. Yet during the day, they are not entirely inactive. Many species use the soft morning or late afternoon light, when the air is cool, to observe their territory, tend to their young, and scout potential sources of food. Different owl species follow distinct daily rhythms. Barn owls and hawk owls are classic nocturnal hunters. The night is their kingdom, and the day reserved for rest. In contrast, long-eared owls and some eagle owls exhibit more flexible activity. Early morning and late afternoon are just as important as nighttime. And observations have shown they can hunt in daylight, though they are not as proficient as in darkness. Their activity depends on what maximizes their chances of catching prey while minimizing risk. Asterisk. Sensory adaptations allow owls to operate safely at various times of day and night. At night, vision and hearing dominate. Asymmetrical ears pinpoint prey in 3 dimensions, while soft-edged wings ensure a silent approach. By day, given sufficient light, their eyesight still surpasses most raptors, allowing them to detect movement from great distances. Seasonal changes shape these activity rhythms. In spring and summer, when days are long, owls adjust hunting hours to exploit variations in light and temperature. In winter, when nights are extended, they hunt mostly in darkness, resting during the day to conserve energy under harsh conditions. Observations have shown that some owls shift their hunting grounds in winter to areas with shallower snow or where rodents remain active even in faint daylight. Some owls also display remarkable flexibility in the presence of humans. In suburban areas, barn owls and hawk owls hunt under streetlights, taking advantage of small rodents venturing out for food. This demonstrates that daily activity rhythms are not rigid. They result from sensory adaptations, ecological pressures, and risk assessment. At night, every movement of an owl is precise and balanced. Silent flight, detection of the faintest rustle, perception of moonlight or starlight, all work in harmony to make hunting effective. During the day, although silence is less absolute, owls still employ their senses to monitor territory and protect their young. This dual activity makes them universal observers of their world, masters of both night and the moments when sunlight allows them to maintain control over their territory and resources. Owls are, above all, solitary creatures. Most species spend their lives alone, patrolling their territories, hunting, and resting in concealment. There are no large colonies or permanent groups. Each owl is responsible for its own survival, its own territory, and its own prey. Yet this solitude does not mean the absence of interaction. On the contrary, every owl maintains clearly defined contacts with neighbors. Territories are marked with calls, vocalizations, and scents, and occasional encounters are brief, sometimes involving rivalry, sometimes avoidance. Despite their solitary lifestyle, owls must cooperate at one crucial moment, raising their young. Here enters a highly precise and complex parental system. The female, often the primary caregiver during the first weeks of the chick's lives, incubates the eggs and ensures that the young are protected from predators. The male, in turn, provides food, sometimes spending entire nights patrolling the territory and hunting, so that the female can focus on safeguarding and warming the offspring. This separation of roles allows owls, despite their solitary nature, to cooperate effectively as a pair. Communication between them is subtle, relying on sounds, body positions, and the rhythm of returning from hunts. Every interaction is meticulously planned. No chaos, no excessive contact. This ensures that an owl's solitary life throughout the year does not hinder the rearing of offspring. On the contrary, it demands an extremely efficient management of energy and time. Some species, such as eagle owls or larger forest owls, may exhibit loose family bonds, where older fledglings remain near their parents for several months, learning hunting and navigation skills. This serves as an extension of the young's training system, preparing them for rapid independence in a solitary world. The solitary lifestyle of owls is therefore paradoxical on a daily basis. They are isolated, forming neither flocks nor communities. Yet when it comes to raising young, they implement a highly coordinated system of cooperation. It is precisely because their social life is limited and deliberate that owls can successfully combine hunting efficiency with parental care, maintaining a balance between individual survival and reproductive success. Owls, though solitary for most of the year, become remarkably socially active during the breeding season, but in a very discreet and precise way. The courtship rituals begin with calls. Each owl has a distinctive tone, length, and rhythm of voice, a signature unique to itself. Males attract females, marking their territory with a sound that says, "Here I am, this is my territory, this is a safe place for offspring." Some species can call for many hours through the night, and the calls are so detailed that a female can assess the male's condition, the size of his territory, and his ability to provide food. In addition to calls, visual ritual comes into play. In larger forest owls, the male displays spread wings, raises his feathers, and performs slow, almost dance-like movements, demonstrating strength and vitality. These movements are subtle, not meant for combat, but to show the harmony of body and reflexes. The female observes, choosing a partner not only by voice, but also by coordination and physical fitness. Once a partner is chosen, cooperation begins in preparing the nesting site. The male assists in selecting the hiding place, brings materials for the nest, or helps adapt it. While the pair does not form a permanent social bond, their cooperation during this time is crucial. The success of reproduction and survival of the offspring depends on it. The female remains the primary caregiver for the eggs, while the male provides food, sometimes even risking his own safety to ensure she has enough energy. Some species display additional behaviors. Males approach the female in a certain rhythm, bring small gifts, or leave prey near the nest, as if demonstrating their ability to provide future nourishment. These gestures, though subtle, are an important part of the conversation between partners, a form of communication that does not require complex social interactions. Courtship rituals of owls are also flexible depending on the environment and season. In dense forests, males use stronger, shorter calls that penetrate the thick foliage. In open areas, they employ long melodic calls that carry for hundreds of meters. Everything is adapted for effective communication in a specific habitat. As a result, the owl's breeding period is a time when a solitary predator becomes part of a coordinated system, where mate choice, precise vocal and visual signals, and the ability to cooperate in raising young all matter. Though the rest of the year an owl remains alone, these few weeks show that even the most isolated creature can, at the right moment, create a functional community for life, for survival. And for future generations, owls are solitary creatures. But not solely by nature, their lives are built around a strong sense of territory. Each owl occupies a defined area which it defends against intruders, competitors, and other predators. The territory is more than just a hunting ground. It is the center of the owl's life, a place for resting, nesting, acquiring food, and protecting offspring. Territorial boundaries are clearly marked. Though not in ways visible to humans, owls use sounds, calls, and sometimes even scents to signal. I am here, this is my place. Territorial limits vary depending on species and resource availability. In dense forests, boundaries are smaller because food is concentrated and hiding spots are plentiful. In open areas, where mice, rodents, and small birds are dispersed, territories can stretch for kilometers. Each owl patrols its borders regularly, flying at night or in the early morning, calling, listening, and checking that no one has intruded. Owls respond decisively when an intruder enters their domain. Males may call, raise their feathers, perform threatening demonstration flights, or, in extreme cases, attack a competitor. Females, while generally less aggressive toward other females, defend the nest and young, signaling danger. Conflicts rarely result in death. More often, intruders are driven away or rerouted. Territoriality also has a seasonal aspect. During the breeding season, boundaries may temporarily shrink or shift to allow contact with a mate and cooperative nesting. After the breeding season ends, each owl returns to full isolation, guarding its borders and conserving energy. Territory boundaries are not fixed geographically, they shift with environmental conditions, food availability, and competition pressures. In winter, when prey is scarce, some owls expand their patrol area. While in years abundant with rodents, territories can be smaller. As each square meter provides ample sustenance, an owl's territoriality shows how a solitary predator balances isolation with effective resource protection. It is a system based on instinct, precise spatial awareness, and subtle communication. Every movement, every call, every patrol flight is part of a survival strategy and a means of maintaining control over its space in a world where competition never sleeps. Owls play a role in the ecosystem that is difficult to overstate, even though their presence often goes unnoticed. They are the nocturnal guardians of balance, natural regulators of rodent and small animal populations. A single owl can hunt dozens of mice, voles, or other small mammals in a single night. Predators that, if left unchecked, could devastate crops, degrade soil, or disrupt the biological balance of the forest. In this way, owls act as natural population controllers, keeping rodent numbers at levels that do not harm the environment or the food. Sources of other animals. Their influence extends beyond simply reducing prey numbers. By selectively hunting the weakest, sickest, or least agile individuals, owls contribute to the genetic strengthening of rodent populations. This quiet nocturnal process functions like natural selection, maintaining populations in health and vigor. Where owls disappear or their numbers decline, rodents multiply unchecked, which can lead to crop damage, increased disease transmission, and ultimately, ecosystem imbalance. Owls are also indicators of environmental health. Their presence tells scientists much about the quality of a habitat, the availability of food, the condition of forests or open areas, and the absence of excessive human interference. A declining owl population serves as an alarm, a signal that something in the ecosystem is not functioning properly, whether it is a lack of shelter, insufficient food sources, or habitat pollution. Observing owls thus becomes a valuable tool for monitoring the state of nature. Their role in seed dispersal or insect control is less obvious, but equally important. Some species hunt insects or small birds, and their activity helps maintain the balance of species within an ecosystem. By operating primarily at night, owls occupy a niche that diurnal predators cannot, effectively controlling populations in areas otherwise untouched. Ecosystem balance depends not only on the number of individuals, but on how different species interact with one another. As top predators within their ecological niches, owls maintain natural zones of equilibrium. Their presence indirectly affects the entire food web when rodents are kept in check. Plants, insects, and other animals can thrive without excessive environmental stress. In practice, this means that every owl, regardless of size or species, is a vital link in the chain of life. From their hunting skill to the precise selection of prey and their adaptability to different habitats, everything they do influences the health of forests, fields, and meadows. Their silent flight across the nighttime landscape is more than a spectacle of nature. It is a daily act of maintaining the balance of the world we live in. Owls play a role in the ecosystem that is difficult to overstate, even though their presence often goes unnoticed. They are the nocturnal guardians of balance, natural regulators of rodent and small animal populations. A single owl can hunt dozens of mice, voles, or other small mammals in a single night, predators that, if left unchecked, could devastate crops, degrade soil, or disrupt the biological balance of the forest. In this way, owls act as natural population controllers, keeping rodent numbers at levels that do not harm the environment or the food. Sources of other animals. Their influence extends beyond simply reducing prey numbers. By selectively hunting the weakest, sickest, or least agile individuals, owls contribute to the genetic strengthening of rodent populations. This quiet nocturnal process functions like natural selection, maintaining populations in health and vigor. Where owls disappear or their numbers decline, rodents multiply unchecked, which can lead to crop damage, increased disease transmission, and ultimately, ecosystem imbalance. Owls are also indicators of environmental health. Their presence tells scientists much about the quality of a habitat, the availability of food, the condition of forests or open areas, and the absence of excessive human interference. A declining owl population serves as an alarm, a signal that something in the ecosystem is not functioning properly, whether it is a lack of shelter, insufficient food sources, or habitat pollution. Observing owls thus becomes a valuable tool for monitoring the state of nature. Their role in seed dispersal or insect control is less obvious, but equally important. Some species hunt insects or small birds, and their activity helps maintain the balance of species within an ecosystem. By operating primarily at night, owls occupy a niche that diurnal predators cannot, effectively controlling populations in areas otherwise untouched. Ecosystem balance depends not only on the number of individuals, but on how different species interact with one another. As top predators within their ecological niches, owls maintain natural zones of equilibrium. Their presence indirectly affects the entire food web when rodents are kept in check. Plants, insects, and other animals can thrive without excessive environmental stress. In practice, this means that every owl, regardless of size or species, is a vital link in the chain of life. From their hunting skill to the precise selection of prey and their adaptability to different habitats, everything they do influences the health of forests, fields, and meadows. Their silent flight across the nighttime landscape is more than a spectacle of nature. It is a daily act of maintaining the balance of the world we live in. Despite their apparent isolation, owls are highly sensitive to environmental changes that can threaten their survival. One of the main threats is habitat loss. Deforestation, urbanization, and agricultural transformation reduce the number of safe places for nesting and resting. Nests and natural shelters that have served owls for centuries disappear, and the lack of suitable trees or terrain crevices forces migrations or limits reproduction. Another critical factor is the change in food availability. Intensive agriculture, pesticides, and chemical pollution reduce populations of rodents and insects, which are the primary diet of many owl species. Food scarcity leads to weakened adults, lower chick survival, and ultimately, declining population numbers. Direct threats from humans include collisions with vehicles, power lines, buildings, and traps. Young owls learning to fly are particularly vulnerable, while adults may encounter conflicts with infrastructure during nocturnal flights. In some regions, illegal trade, poisoning, or hunting pose localized threats to owl populations. Owl conservation requires multi-level actions. Preserving forests and natural areas, installing nesting boxes, controlling chemicals, and educating the public are just some of the ways to enable coexistence between humans and these nocturnal predators. Scientific research allows for monitoring populations, locating territories, and implementing conservation strategies that protect owls while maintaining the balance of the ecosystems they inhabit. Hide more mysteries than one might assume at first glance. For example, they do not blink in the traditional sense. Instead, they have a special nictitating membrane that moves horizontally, protecting the eye while simultaneously moisturizing and cleaning it. This allows owls to observe their surroundings for hours without losing visual sharpness. Even while hunting in rain or snow, their eyes are not spherical. They are actually tubular, enabling them to focus light and see in low light conditions. This allows owls to detect even the slightest movements of prey in complete darkness. Their eyes are fixed, they cannot move within the socket, so owls rotate their heads up to 270 degrees. giving them an almost panoramic field of view. The hearing of owls is equally remarkable. Some species can detect the movement of a mouse beneath a layer of snow, thanks to asymmetrically positioned ears that allow them to precisely determine the direction and distance of a sound. Even in total darkness, they can locate prey with centimeter-level accuracy. Some owls respond faster than a human radar. The sound itself becomes a spatial map. Culturally, the image of the wise owl originates from Greek mythology. Athena, the goddess of wisdom and strategy, was always depicted with an owl at her side, which popularized the owl as a symbol of intelligence and foresight. In indigenous cultures, however, owls had various meanings. Some were seen as harbingers of good luck, others as warnings of danger, and their calls were interpreted as messages from the spirit world. Owls also possess an exceptionally sensitive sense of touch in their feet and beaks. Their toes are covered with sensitive receptors that allow them to detect the slightest vibrations of prey or the surface of a branch, even in complete darkness. Some species can even search leaves or snow with their beak, detecting hidden insects. Another fascinating feature is their ability to adapt to different environments. Some owls live in open deserts, others in dense forests, and still others in mountains. Their bodies, feathers, flight, and senses are all adapted to the specific environment, ranging from silent flight in the forest to rapid diving over the steppe. The owl is a creature that embodies the mystery of the night, the precision of a predator, and the symbolism of human imagination. It is a solitary observer of the world, able to see where others see only darkness, to hear what remains silence to us, and to move in a way that keeps it almost invisible.